7.2, graphing more polynomial functions. So this is just a little extra information on graphing. So it says when we graph polynomial functions before, we made sure to find the zeros, so the x-intercepts with factoring. We also found the y-intercept, right, by plugging in 0 for x. But sometimes zeros aren't super easy to find. So sometimes the zeros aren't like exactly at -2 or -3, right? It's between -2 and -3. Also, when we graphed before, we didn't know how high or low parts of the graph went. And I told you before that if you want to find a maximum or a minimum, you actually have to take calculus. So we're not going to like find that exact value in this class, but we can do some things to estimate it. So a relative or local max is just a point on the graph of a function where no other nearby points have a greater y value. So if you have something like that, then in this general area, that would be called a relative max or local max. Okay, now notice that is not the highest point on the entire graph because with my end behavior, I've drawn it going off forever to the right, correct? So it's not the highest y value possible, but in that general area, it's the highest point. I always talk about like Dr. Seuss's Whoville. So like those little like who's that live on that hill, they think it's the highest point. They're not anywhere near those other ones. So relative max. Okay, and then the relative min would be something like this. So you can call that a relative min or a local min. Which one you call it? Yeah, different books will call them different things. So some books will say relative max, relative min, and some will say local max, local min. Yeah, same with the absolute. Like if you talk about eventually, like this is both a relative max, but it's also what we would call an absolute max. Sometimes they call it a global max. So, all right. So it says graph f of x equals negative x cubed minus 4x squared plus 5 by making a table of values. Use the end behavior to help you. So if you look at this one, we don't know how to factor that. It has an x cubed, right? So we're not going to be able to find those zeros perfectly. But we can use a table of values to estimate. So we're going to do a t-table. And we're going to plug in different things. So let's say I plug in 0. When I plug in 0, I get 5. So that's my y-intercept. 1, 2, 3, 4, 5. And let's plug in some things around that. So maybe like 1 and -1. So if I plug in 1, I get -1 minus 4 plus 5, right? I'm putting the 1 in. So 1 cubed is 1, 1 squared is 1. So that's a 0. That's good. So that's an x-intercept. All right, and then -1. Well, that's going to be negative and then -1 cubed. Minus 4 times -1 squared plus 5. So the -1 cubed is -1. But then I have -1 times a -1. So that's going to end up being +1. Yep. And then I have -1 squared, which is 1 times -4. So I'm going to have +1 minus 4 plus 5. So I get 6 minus 4, which is 2. So -1, 2. Okay, so you can't just say, oh, I have 3 points, I'm going to draw in a parabola. It's going to be this downwards parabola. It's not, right? It's not going to be a downwards parabola. How do I know what shape it is? What shape should it be? Yeah, Gloria, what do you think? Yeah, so she drew the x cubed, and she said it was an upside down x cubed, right? Do you guys remember what we talked in 7.1? So end behavior. So our end behavior, since we have an odd degree and it's negative, it should look like negative x cubed on the ends. So we should definitely have something like this. So if you aren't sure what's happening, you can plug in a few more points. You can plug in some things over here. Let's say I plug in -2 or -3. So how about the right side of the room, you guys plug in -2 and tell me what you get. And the left side of the room, you guys plug in -3. Anybody have their answers? No one has any guesses? Are they so big that you just don't want to say it? Yeah, Eric, what do you think?
2.
what about negative 3? Yeah, Olivia? No, close though. It's a small number. Yeah. What'd you get? Negative 4, yeah. Okay, so I have negative 2, negative 3, and I have negative 3, negative 4. And so we're curious. We're like, oh, does it keep going down like that? So I would try another thing. I would try like negative 4, negative 5. So when I try negative 4 and negative 5, negative 4 gives me 5, and negative 5 goes way up high. It gives me 30. Okay, so I plug those in to see what I got. So negative 4 gives me 5, so I'm above the axis again. And then the other one gave me 30. So that means that I would have to have a 0 between negative 3 and negative 4. Do you guys understand what I mean by that? I have to, when I'm connecting these dots, I have to cross the axis somewhere between those two values, right? So I'm going to connect, and when I cross, it's somewhere between those two. And then the rest of the graph should look like that. Okay. So it's not fun to do that way. Do you guys agree? T-tables are not fun. So if you're able to factor and do the things we did in 7.1, that's really the best way. And those are really the ones that I put on the test. I don't put like T-table ones really, because I think it's kind of annoying. Yes. You do not have to find the exact 0. Now there are methods to try to approximate the 0. Like once you have negative 3 and negative 4, then you could plug in like negative 3 and a half. Right, negative 3.5, and then negative 3.75, right? You can keep making the interval smaller and smaller, but we don't have to do that. All right, one thing that I do if I have to do a lot of t-tables, I'm going to show you a trick. So if you have your graphing calculator, you can go to y equals, and you could go ahead and, I mean, you could graph this function, and you could see what the function looks like. You know it's going to be a downwards parabola. Can you guys see it on the screen? It's kind of hard to see with the green. Let me hit. So I put it in for y equals. So I know that it looks like that. So this is if you're on a calculator test, and you know that half my test is not a calculator test. But there's something very nice on your calculator, and I want to show you what that is. Okay? So you can create a t-table on your calculator. Isn't that awesome? So you just go to y equals, you put in the function, and you can hit graph and see what it looks like if you want to. But do you guys notice above the word graph, what does it say? Table. So if you do second table, then you have a t-table here for you. So you can plug in those different things. You can arrow up and down to get different y values with it. So see how I have 35, negative 4, negative 3. We had all those values. But the thing that I like to do is not use the values that were given to me. I like to be able to put in whatever I want. So if I wanted to see what happened at negative 3.5, I can do that. So what we would do to change your calculator is we would go to second. So do this along with me. So second table set. So table set is the second button. So if I do second table set, I want it so the independent isn't on auto, but instead it's on ask. So if you do that, and it will always be set up like that unless you need to go back in and change it. When you now go into table, it's blank. And you can put in whatever values you wanted to. So in our t-table, we had 0, we had 1, we had negative 1. So you can put in all those different things. Does that make sense? Do you guys like that function? Yay, calculator. So we get all those different values that we had from before. Are you like, why didn't you show this like first semester when we had to do t-tables? All right. Okay, so put that away. So let's do it for this one as well. So it says determine the consecutive values of x between which each real zero of the function is located. Then draw the graph. So if I have x to the fourth minus x cubed minus 4x squared plus 1, I know that the end behavior is going to be like that. So I don't know what's happening in the middle, but I know that the ends are going to both go upwards because it's an even degree and it's positive. So if I'm coming up with a t-table for this, I'm going to plug in different things. I know when I plug in 0, I get 1, right? I can plug in 1 and get something else. Do you guys want to use that t-table that we did before. So we can go to y equals, we can clear it out. We can put in x to the fourth minus x cubed minus 4x squared plus 1. And then I can go to my table and I can put different things in. So if I put in 0, I get 1. If I put in 1, I get -3. If I put in -1, I get -1. So 0, 1. Oh, why did I put 0, 1 there? You guys didn't even say anything. Were you like, oh, she's good. 0, 1, 1, -3. -1, -1. All right, let's try like -2. What do you get when you plug in -2? Did you guys do that? Help me out so I don't have to keep going back to that graph. -2? Maybe do on the table? What'd you get? You're working on it? I'm just a speedy typer. -2 gives you 9. -3 gives you 73. That's way up there. So -2 gives you 9. -3 gives you 73. So we have -2, and then way up here at 9. Okay, and we know our graph is going to go up, right? So we're definitely doing something like this. And then I bet if we plug in 2, 3, and so on, it's going to go back up on the other side because we have to have that end behavior. So what if I plug in 2 and 3? What'd you get when you plug in 2? Negative what? 7, and then 3? Okay, so since I was -7, so 2, -7, 1, 2, 3, 4, 5, 6, 7. And then all of a sudden I was way up here at 19, 3, 19. What does that mean? Where does it have to cross? Between what two numbers? Between 2 and 3. Do you guys understand what I'm saying? So we have to cross somewhere between 2 and 3. We have to cross somewhere between 0 and 1 because, see, it goes positive and negative. We have to cross somewhere between -1 and 0 because I have a positive and a negative there. And we have to cross somewhere between -1 and -2. Oops. -1 and -2. Do you guys understand what I'm saying? Zeros between. Because you have to have like a continuous curve, like you can't like skip over things. And so if you have a positive value and a negative value, you have to cross between those two x values. So between -1 and 0. Did you guys see it?
What about on that?
So this one as well. Yeah, we need this one circled as well. So we have 4 zeros.
How do you know where that last zero is?
It's between the 2 and the 3. So our zeros are between. So we have between -2 and -3. So let me write it -3 and -2. Kind of write it in that order as if I was writing it as an interval. The second one was between -1 and -0, or not -0, -1 and 0. The third one was between 0 and 1. And the fourth one was between 1, 2, 2 and 3. Exactly. Does that make sense? Yeah, cool. It will not, because we know that in behavior. We know it shoots up like that. And there's also an important theorem that we're going to learn in section 7.4, so coming up. So notice this last problem. We had 3 zeros. Do you see those 3 places where it's crossing? All right. Look at its original, the original function. Do you guys see how it's x cubed? Look at this next one. We had 4 zeros, 4 places it's crossing. Notice what we had. X to the 4th. So if I had x to the 5th, how many zeros could I have? 5, exactly. So it's not saying that you always have 5 zeros, but you can have at most 5 zeros. And what will happen is sometimes they have multiplicity. Like sometimes an answer is an answer 3 times out of the 5, right? But that's the most times it can cross. All right, so sketch a rough graph. So let's do one more of these. So this is another multiplicity problem. Okay, so this is one that would have nice zeros because it factors. When things factor, that's good for us. It's easier to graph. We don't have to use the t-table. All right, so the first thing I want to find are my x-intercepts. So if I plug in 0 for y, I get 3 solutions. One of those solutions is an answer twice. So I get x equals 2, which has multiplicity 2. I get x equals negative 2, and I get x equals 1. Or, sorry, not 1, negative 1. So at 2, negative 2, and negative 1, I have zeros. My y-intercept I get by plugging in 0 for x. So if I plug in 0 for x, I get 0 minus 2 squared times 0 plus 2 times 0 plus 1. So I get negative 2 squared is 4 times 2 times 1, which is 8. So my y-intercept is 8. And my end behavior, if I did multiply this all out, what would my leading term be? What would that first term be? X to the what? 4th, right? There's just one x to the 4th. There's not a negative or anything. So it's x to the 4th. So when I have x to the 4th, that means the ends of my graph are both going up. And we don't know what's happening in the middle. It's going to be like that. Now one of these has multiplicity. Remember this one right here had multiplicity 2. So we're going to be very careful when we graph it. Otherwise, it's going to go straight through, just like a line. So we're going to go straight through this one, up to the y-intercept, down, and then it's going to have to bounce, right? So it bounces back. Straight through, and then bounces right there. Because they were these numbers right here. They were the x-intercepts.
Oh,
That makes
the
sense.
X-intercepts running like on the ones that we talked about. Oh, wait, never mind.
You see it? And then we don't know about the maximum, like that 0, 8. We don't know if the y-intercept is the maximum. It could go up past it. So if you're not sure, I mean, you can always draw it past it. That's fine. And if you wanted to find that point, you could plug in maybe 1 to see if it goes up higher or not. All right, does that make sense? You guys get it? All right, we're going to stop there.